So, I guess that the tiny bit done on this one is that I actually clicked the last one yesterday, not to lose the streak, since I was doing other stuff on stream. Yeah, so let's start from the top. I could have just clicked the first one, I guess. So, no, nothing to start here. Just listing that it's one of the series. And an image that we've seen already, right? In the last room. In Nmap, first, it's called Nmap Advanced Port Scans now. Ah, right. I didn't change the stream title, did I? Let's see what it says. Okay, sorry if someone hopping in here for on streaming. I think that I won't continue that. I could though, but I'll actually copy the name of this and I'll put it here, and let's add learning. Oh, we could just stop. I'll skip it there. Try me come. Sorry. Oh. So I actually did a test stream yesterday, kinda late. Well, this morning, I guess. Since I was up with my kid anyway. On the other channel, just playing a mobile game on stream, and it was horrible. It was really, I'll never do that again. And it was just boring, you know. That game I usually played because, you know, I had to wait for a bit, so let's. But it's not really. It doesn't have a purpose. There's nothing much to do but to merge things. It's a merge garden one. So it's very slow and boring. So if I am going to play a game on the stream, it will be something more fun than that. Maybe better to learn something, but I'm kind of thinking when it's past midnight and you're not in top shape from it actually being past midnight. So, alright, I know why I had it like that. Learn advanced techniques such as null, fin, Xmas, and idle zombie scans. Spoofing, and in addition to FW and IDS evasion. So firewall. Sorry, as I said, I just woke up, so got a bit of asthma stuff in my throat, I guess. We cover TCP flags and view TCP three-way handshake. To initiate a connection, TCP requires the first package to have a SYN flag set. Consequently, we can tell if the TCP port is open based on the response we receive. Security researcher and hacker contemplated the TCP flags shown in the figure below and examined the previous room and started to experiment. They wanted to know what would happen if we send a TCP packet which is not part of the ongoing TCP connection with one or more flags set. Oh yeah, they were talking about Christmas and things there, right? For instance, The X flag is set when you want to acknowledge received data. An X scan is like trying to acknowledge data that was neither sent nor received in the first place. Consider this simple analog. It's so basic, I'm going sad here. Someone coming to you out of nowhere and saying, "Yes, I hear you, please continue," when you haven't said anything. This room explains advanced types of scans and scan options. Some of these scan types can be useful against specific systems, while others are useful in particular network setups. We will cover the following types of port scans. Yeah, Nullfin, Xmas. I'm not sure I've heard about Maimon. Mac, Windows, Custom. Moreover, we will cover the following: spoofing IP Mac, decoy scan, fragmented packets, idle zombie scan. We can discuss options and techniques to evade firewalls and IDS systems. We will also cover, to get more verbose details from Nmap. Maybe I should have eaten before I started the stream, but that was so late already, you know? I'm supposed to start at 13. Also, I'm thinking tomorrow, tomorrow or in the weekend, one of the days, I will probably do like a birthday stream, and I'm thinking of doing the robot arm thing that we've been just like pausing because of studying, or some other electronic things. We'll see. Maybe we'll start with the robot arm and see where we go from there. So probably the robot arm tomorrow, and maybe I'll do a longer like birthday stream in the weekend. We'll see. So, let's start that. And let's also start the VM. I'm curious which VM would actually be the best, but I guess I'll do my normal Kali for everything, though we have another one now too, to test the communication after the file copy program we're making. Right. I haven't even started my switch screens phone app. So let's do that. So annoying to have like slime in your throat when you're trying to do stuff. Like talking. I'll be able to switch screens soon. I'm just logging into Kali. And There we have the, so I can switch. Maybe I'm so allergic because I'm born at this time with a lot of pollen. I don't know. Darn allergies. Let's start with the following. Okay, I'm sure these have been in rooms before. I'm sure. So I think we can see this without clicking. But let's also open the notes. And here, because I was making notes on the previous Nmap room. So we have this for scanning a network, and then we have this for starting to scanning port like normally, right? And this is details from that room too. So let's do like more advanced scans or something. Since that's the structure of the rooms, it's kind of nice to have it, the structure here too. Well, maybe I should check how I spell stuff. So, these are my older notes. So everything started, except me that needs a bit more food. So, null scan. The null scan does not set off any flag. All flag bits are set to 0. You can use this scan using the SN option. A TCP packet with no flag set will not trigger any response when it reaches an open port, as shown in the figure below. Therefore, from Nmap's perspective, a lack of reply in a null scan indicates either the port is open or a firewall is blocking the packet. However, we expect the target server to respond with a RST packet if the port is closed. Consequently, we can use the lack of RST response to figure out the ports that are closed, open, or filtered. Are not closed, open, or filtered. Below is an example of a null scan. So I'm thinking, let's make notes on this because that's all there is. So we have SN, and these notes are going a bit long, I know. This is more like learning than the useful commands, so I'll probably put useful commands on top, though it's kind of rare to hop in here, right, into Nmap notes, because you have it all in your history if you need help. It would be fun to actually use these more advanced things sometime, and it being useful, right? So first I had like, so remembering the format. First, what it is, this is a null scan. No flag set. Will get no reply from an open port. But a RST from a closed one. No reply equals open filtered. There. So maybe I should have this at the start. Well, it's not that long to read, right? And then we want an example. So let's take this one and hope that copy works. It did. So we get open filtered on these. When we do the scan, note that many Nmap options require root privileges. Unless you're running Nmap as root, you need to use sudo as in. Yeah, and I'm thinking we need this for all of these, right? So I'm adding to the header sudo rec. Then we have the fin scan. The fin scan sends a TCP packet. Let me start the notes at once. Fin scan. With a fin flag set, which is kind of obvious, right? You can choose this type of using the SF function. Similarly, no response will be sent if the TCP port is open. Again, Nmap cannot be sure if the port is open or if a firewall is blocking the traffic related to this port. However, the target system would respond if the port is closed. Consequently, of course, we will be able to know which ports are closed and use the knowledge to infer the ports that are open or filtered. It's worth noting that some firewalls will silently drop the traffic without sending RST. Yeah, so what I'm thinking is, yeah, they sending RST ACK. So I just said RST because they are saying that in the text. Maybe I should add RST ACK to the other note, and then we'll just simply copy this bit. Okay, since it's the same, right? Below is an example of a fin scan against a Linux server. The result is quite similar to the result we obtained earlier using a null scan. I'm kinda a bit annoyed at these rooms because it's just a help file, you know? And I'm starting to think, should I even put this in my notes? Or should I just ignore these and continue with something else? Or just quickly go through them and don't even read it, you know? We'll see. Well, I guess it won't take that long. Xmas scan. So, again, I'm starting the nose at once, so it doesn't take much time less, so... Xmas scan. And it's... the Xmas scan gets its file after the Christmas tree lights. An Xmas scan sets the fin... sets fin PSH and urgent flags. I'm just changing how I wrote it. Flags set there. You can select Xmas scan with the option SX, like the null scan and fin scan. If an RST packet is received, it means the port is closed. Otherwise, it is reported as open filtered. The following two figures shows the case where the TCP port is open and closed. So we get RST ACK again, meaning we can copy the same note, making sure you're not on the note page because it's kind of unimportant to see me copying something, right? Then we copy this and we have the same kind of output again, right? Does it say anything about... I mean, it's just the same thing. So they could have just put these in a block, but I guess it's good for someone who's never even heard of these to have them separated. So just... I'm not switching back and forth between the nodes, but they look like this now with these three. Almost the same, all of them. One scenario where these three scan types can be efficient is when scanning a target behind a stateless, non-stateful firewall. A stateless firewall will check the incoming packet has the SYN flag set to detect a connection attempt. Using a flag combination that does not match the SYN packet makes it possible to activate the firewall and reach the system behind it. However, a stateful firewall will practically block all such crafted packets and render the scan useless. And it's because there's not a connection ongoing, I assume. How many flags are set to what in a null scan? In a fin scan, how many flags? In an Xmas scan, how many flags? Start the VM and load the attack box. Once both are ready, open the terminal on the attack box and use Nmap to launch a fin scan against the target VM. How many ports appear to be open filtered? Okay, so let's go to the VM. And we need to start the VPN. There. I'm typing before it's there, that's useless. So, let's just see, we were supposed to do fin scan, right? And checking, it's SF. So, dash SF, no, typing in the wrong spot, SF, and the IP is 10.217.174. And people, you're welcome to talk to me. Everybody being quiet. So, of course, we need sudo. And there. Let's see how many ports. Thank you so much, Digital Warhead. Thank you. Thank you very much. So, how many ports? 7. Oh, and you've been subscribing for 3 months. That's so kind of you. Thank you. And I can't really realize, was it that long? Was it that long ago? I know I've been streaming for longer, but I started streaming a bit more lately, right? You know. So let's just give it the response here it wants in the and try hack me 7. Repeat your scan, launching a null scan against the target VM. How many ports?
D-Dub says,
Good morning. I haven't been on Twitch lately, but your streams are so early for me.
Yeah,
5 a.m.
yeah.
here.
Oh my god, it's 5 a.m. It's afternoon for me, you know. Alright, so that's why you're awake late there. Because it's 14 already. Ah, that's quite a huge time difference. I've been thinking about that I should do some streams later. Then, because I'm doing morning sometimes, and then you're definitely asleep, right? And I expect most Americans will be sleeping at those hours. But these afternoon streams are kind of like in the middle, and I usually go a bit longer than 17. That's the scheduled end time, but still it's kind of early for you still, right? And I'm not streaming in the weekends usually. I'm thinking maybe I should like schedule one of the streams like later instead. We'll see. I'll have to do something later at least, right? I'll have to do that. So let's do the null scan too. And I think it's actually shorter to just scroll up here to confirm. So null scan is N. Surprisingly, or not surprisingly.
I work at 6 a.m., so I'm just getting ready to head out the door.
Ah, okay, yeah. That's an early start of the day anyway, 6 a.m. So have a great day at work, and I hope to see more of you, Digital Warhead. I hope to see more of you. So what do you do at work if you have time?
It is early, but it's nice getting off work at 14:30.
Right, that's nice. You have all of the day almost there. As I woke up at like 12:45 today. That's crazy, right? But it's already it's a
I manage a
day off.
P25 radio network.
Okay. Oh, so that doesn't tell me much. P25 radio network. Tell me more. If you have the time, of course. If you have to run to work, I get it. But maybe you just woke up. So we have... Let's just see that there are the same ports. And they are. So we have 7 again as a reply to the question. Then we have the one I had not heard about, at least that I remember, Maimon scan. Uriel Maimon first described the scan in 1996. In the scan, the fin and ACK bits are set. The target should send a RST package as a response. However, certain BSD-derived systems drop the packet if there is an open port, exposing the open ports. Okay, this scan won't work on most targets encountered in modern networks. However, We include it in this room to better understand the port scanning mechanism and the hacking mindset. So that's kind of why I haven't heard of it then, right?
P25 is a standard for public safety radio networks. It's been around for a while but mandated in the US after 9/11 due to all the responding agencies not being able to communicate with each other.
Oh, okay.
Web
okay.
link.
Oh, cool. Thank you for teaching me. So, standard for public safety radio networks. And here it says, interoperable digital two-way radio product. P25 was developed by public safety professionals in North America. And it's again acceptable for public safety, security, public service, commercial applications worldwide. So then it's kind of new. Cool to maintain such a thing. So it's supposed to work everywhere, right? So you have a lot of. How does it work practically? What do you do in your workday if you have time? If you don't have time, it's fine. I'll just read more. So, it sounds very cool. P25 compliant technology is being deployed over two main phases. For future phases and yet to be finalized. And we have a thing here, or radio, I guess you call it, right? Antenna.
I wish I had more time, but I'm just heading out now.
Yeah.
It's multiple sites connected across a large geographic area that all communicate with each other. If other agencies need to jump on our network, we can do so.
Cool, very cool. And I guess the range must be kind of good, right? It's probably in here. But thank you. I won't ask any more questions, Digital, and hope to see you soon. And have a great day at work. So I can just search it.
Okay, bye. Have a great one.
Yeah.
Thank you.
Thanks. Bye-bye. You got something new for me to learn here. So, I think that was the only mention of range, though that's probably not that. Encryption. I won't. I will continue the room and I'll read this later, because it's very interesting. So let's continue reading. Most target systems respond with a RST packet regardless of whether the TCP port is open. Yeah, in such case, we won't be able to discover the open ports. The figure below shows the expected behavior in the case of both open and closed ports. So, case TCP port is open or closed, certain systems drop the packet when the port is open. So, almost always there's RST, and now it's RST only. Well, I guess I will add it to my notes, because we have notes. let's add something like uncommon to it or something. So I'm going to type here SM and Mime scan uncommon fin, and I was thinking of that in the last one. I'll just do an and character and hoping that the line will be a bit shorter at least, though it wasn't. Nah, it doesn't look good, right? This is just normal text. That'll have to do. Set. And well, flags set. The console output below is an example of a TCP MAMO scan against the Linux server, as mentioned below, or mentioned, because I'm adding words for no reason. Because open ports and closed ports are behaving the same way, the MAMO scan could not discover any open port on the target system. So it's said here that certain BSD-derived system strap and none other. So sometimes, yeah, I should add this to my notes. Only, or rather here, we don't have to say uncommon. We can say both an open and a closed port will send RST back, except for some SD derived system that drops the packet. Much longer notes, but I feel that this is so usually doesn't work. Well, why do we have it in our notes when it's very, very seldom it works? So if we would find a port with this one, it would be like, whoa, we already know a bit about the OS here, right? Oh, we'll have to try this sometime. Sometime I need to experiment. And this is kind of all of this task, I guess. We're supposed to actually find something now, I guess, because if it's not, if we don't find anything, then this was just boring, right? So we'll need, please give us a reply here. Nah, we didn't get anything. Maybe they didn't even find some box that, or some OS that actually gives a reply. So no, not correct. So let's see. Not a new box to start. I did sudo nmap sm 1010. Okay. Yeah, I assumed there would be something, but 0 is not the correct answer. Meaning, maybe we'll have to do like all ports. We'll see. Let's see. Maybe a good opportunity to eat a bit more, but I think I'm full. So I have yogurt too. And you're very welcome to chat with me while we're waiting. And apparently we didn't get anything. So room 4 Nmap VM3. So VM3. I'm kind of curious now because they in the example get no replies. I've done exactly the thing, so let's try 0 again, because that's what we actually found. So this is kind of boring, but we were supposed to find 2, so that's kind of a bug here, but whatever. It would have been fun to find something. The ACK window and custom scan. This task will cover how to perform TCP ACK scan, a TCP window scan, and how to create your custom flag set. And we need to terminate this machine to start this one. And maybe we should start with doing... Sorry. And I'm always tired, even if I just like, but I'm not tired. I'm just look like I'm tired, right? So, sorry, my nose itches. Waiting for the IP. I'm going to start with the scan on this machine, the old one, the Myman one. And I'm still thinking about the radio network here. 25. Oh my god. I'll just mute.
Haka says.
Previous question asked about flags, not ports.
So it was just me misreading the question, thank you. Because I was thinking it would be so fun to have a reply. That's why I wanted to read it that way, I guess. So let's look. I guess I'm sure you're right. You know? Yeah, how many flags are set? And welcome back, Haka. So I should read the actual question before, not just assume. I just wanted to have a machine that I could get a reply from. So we have an IP. I'm just quickly going to... I assume there won't be a reply on this one either, but... Oh, I'm typing the IP without having clicked the machine. 140, so I'm assuming nothing. I'm assuming the same. We could do, you know, a better scan to see the OS of the machine. Well, let's go to the notes. Giving up on port. Well, we'll see if it finds anything there when we get back. So, the TCP ACK scan. I mean, TCP ACK scan. Didn't we already have that? No? We didn't. I was just thinking we had. So, let's start with the TCP/ACK scans. As the name implies, the ACK scan will send TCP packet with the ACK flag set using the SA option. So, dash SA in the notes, and this is TCP/ACK scan. And kind of obviously, but okay, ACK flag set there. Open to choose this. Use the option to use a scan. As we show in the figure below, the target would respond to the ACK with RST regardless of the state of the port. This behavior happens because TCP packet with the ACK flag set should only be in response of received TCP packet to acknowledge the receipt of some data, like our case. Hence, this scan won't tell us whether the target port is open in a simple setup. So, in the following example, we scanned, as expected, we couldn't learn which ports were open. So, why? Is there more information? I guess. This kind of scan would be helpful if there's a firewall in front of the target. Consequently, based on which ACK packets resulted in responses, you will learn which ports were not blocked by the firewall. Yeah, I expected that. In other words, this type of scan is more suitable to discover firewall rule set and configuration. It's not for the actual bugs. I've been setting up a target VM with a firewall. We repeated the ACK scan. This time we received some interesting results. So, okay, so now we're getting responses here. As we see in the console output below, we have 3 ports that aren't being blocked by the firewall.
Money on Throat says, your IP address is on open.
So, welcome in, Money on the Road. And maybe you learn something, maybe you can teach me something, we'll see, right? This, yeah, so they added a firewall, that's why we started a new one. This time we're seeing some interesting results.
I am new as well, don't worry.
So, welcome in. A scene. But I like people teaching me stuff too, so, and also noobs can teach each other, right? A scene in the console output below. We have 3 ports that aren't being blocked by the firewall. The result indicates that the firewall is blocking all other ports. What I'm curious about here is that the difference here, it would have gotten replies on all of them, right? And here it didn't get replies on the other ones, just on these. So it's intelligent enough to realize that when it gets replies on all of them, there's no results. Shouldn't it have been saying like none of these were blocked, right? And here these were not. It's just the logic of Nmap that I'm thinking of here. So let's make the notes. All, I'll hop over there. All ports will always Respond with RST. Meaning we can use this for detecting ports blocked by a firewall. There. Or should I do FW just to get...
Why do you want to learn hacking?
I've worked in IT a lot, but now I'm home with my kids. So part of it is that I would like to work remotely. But part of it is also that I found this area for about a year ago, and it's very interesting. So that's why I want to learn it too. But I want to learn like everything also. But it is very interesting. Very, very interesting. So we're going to copy this as example. So why do you want to learn it? Tell me.
Yeah, I agree, it is super cool. Haka says.
Question is why would you not? D.
Yeah. Exactly. So why would you not? I guess that for a lot of people, for me this is like, oh my god, this is too simple. Should I even do this room? But most people will be like, oh my god, what's an IP address? You know, like just generally in society, old people don't know about flags. What's a flag? Oh, it's on and off something. Binary. What? I don't get it, you know? So kind of, maybe it's that there's more stuff. I like the low level too, and this is kind of like low level. But I want to know all of the things in this, you know? All of the details of all of the fields. Though I've kind of seen them a bit, you know, but I don't like people starting with, you have to learn the layers of the OSI model. You know, that's like, oh my god, that's boring. And learning names for things and acronyms, nah. But the details I like. So that's how I think and what I like.
Money on Throat says. Do you have a degree?
No, I don't have like a degree in. I just started working with. I started working like in '96 with phone support. First for users, and then for more like servers, and then I was responsible for Electronic Arts Nordic in IT. And then I worked at another company, and you know, and then I got kids, and then I didn't work much with this. I worked with other stuff. So back then we had like a frame relay line that used to go down, and we had a backup, and we had it was a mess back then with the networking. So there, a few rooms ago, it was, oh, this is traceroute. I was like, oh yeah, I kind of used that, like 1996, you know? So it's a mix. Everything connects back to my old knowledge. So it's always fun to learn things. I like learning things. And that's the part where I like this too, because it's not static, you know? Cybersecurity will always change. That's the whole thing with it. You will never be expected to just like, oh, you don't have to learn anything more. You can just do the same thing all the days of your rest of your life. That will never happen. Right? We're safe. We're safe. It won't go static.
Are you afraid AI will take over all the tech jobs?
What AI? Because there's not AI yet, you know. There's just LLMs. And they just do crazy stuff that's not correct. Lots of the time. So, if AI actually...
Yeah, maybe in 100 years.
Yeah. So, of course, you know, the Terminator movies could happen. And that doesn't even have to be AI. It could just be a stupid program defense system, saying that if this thing is dangerous for the planet, it's easy logically to see how humans are the most dangerous thing on the planet, right? So it doesn't have to be AI for that either. We'll see. Maybe someone gives LLM the power and eat bugs. Let's see now. No. I was done with the A1. But this is not this is the window scan, so this is what I'm supposed to read. So what do you think? Will AI ever, or computers ever, take over? Or will we manage to kill ourselves instead? Which would it would actually be, even if it would be like that. But, just environment
Haka
catastrophes.
says,
AI yet doesn't exist, it's overused
Yeah,
to sell you
yeah.
products. What we have so far is just ML.
Yeah, exactly what I said. It's just LLMs. So
In
it's
100 years we will probably be gone lol.
Yeah, but will it be like a technical thing, or just us messing up, or warring, fighting, sending bombs to each other and just wiping everything out? Hopefully, smart people will be in control of powerful things and will be able to cool stuff down, right? We never know. And, you could go like all depressed and say, oh, humankind is so horrible, we do this and that. But, this is life. Why not enjoy it?
Money on Throat says, bringing AI to military will be the end of humanity.
Yeah, but maybe AI, if it's actually AI, will be smarter than humanity and will save us instead. If we would try to make LLMs make decisions, then it will be the end of humankind, probably. But if it was actual artificial intelligence, it might not have the egoism of humans.
Yeah, that would be a happy ending, haha.
So we'll see what happens if we're live. Otherwise, we won't know. So just enjoy life while you have it. That's kind of my thought. So, window scan. Another similar scan is a TCP window scan. The TCP window scan is almost the same as the ACK scan. However, it examines the TCP window field of the RST packets returned. On a specific system, this can reveal that the port is open. You can select this scan and use SW. As shown in the figure below, we expect the RST packet in the reply uninvited ACK packets. So, on specific systems,
My
this
friend
can
Phil
reveal-
McCracken is really interested in learning about hacking.
Okay. On specific system, this can reveal that the port is open. The TCP window scan is almost the same as the ACK scanner. It examines the TCP window field of the RST packet returned, so it looks more closely. So we get an RST, but we look at it what it actually is. Similarly, launching a TCP window scan against a Linux system with no firewall will not provide much information. As we can see in the console output below, the results of the window scan against a Linux server with no firewall didn't give any extra information compared to the ACK scan executed earlier. However, as we would expect, if we repeat our
Cocaine 1
TCP
PT
scan,
says, hello.
Hello.
What we doing here?
We're going through all the rooms in the junior penetration testing, and it's kind of slow. It's just doing Nmap
Money
right
on
now.
Throat says, hacking is a broad term that encompasses various
Sure,
activities,
go for
but
it.
generally, it involves gaining unauthorized access to computer systems, networks, or data. Here's a simplified explanation of how hacking works. Reconnaissance. This is the first stage where hackers gather information about their target. They might use tools like port scanners, social engineering techniques, or simply search online for vulnerabilities. Scanning. After gathering information, hackers scan the target's network. Cocaine 1 PT says, cool? I'm just having a break from work.
Yeah, so
Haka says,
Money on throat okay, chat GPTD.
yeah, I'm sure. I can mute a TTS message, by the way. It's not an ad or anything. So go for it, but don't spam chat too much, okay? With TTS messages.
Money on Throat says, Haka, how did you know?
So
Okay, sorry.
So okay, I'm going to have to check how to read your name. Cocaine 1 PT. I know. You know? So hope you're having a great day at work. And a great break. But I have to go and make some pancakes. I'll be right back. So right, so the difference between the Windows scan
Cocaine
and
1
the X
PT
scan
says,
is what we're
huh,
at.
not bad.
Okay. I'll be right back. I'll just go get some pancakes for myself.
Some attempts of XSS
microwave them.
and SCLI as usual.
Okay.
Money on Throat says, enjoy the pancakes.
Yeah, so please send some. Right, I forgot to put my ear thing in. You can tell me if there's an echo, you know. I can't hear it, because I hear my speakers. But I usually put this in so you don't have the echo of the TTS going through my speakers into the microphone. So you can talk and I will hear it. I'll be right back. I'll just microwave some pancakes.
We can see your Amazon card details. La? La 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 la. Translated from Tagalog.
So, I'm back. La 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 la. Allergies. So, right, I closed the door. There. So, I'm just looking at my OBS. Something like that, maybe there. So, and I'm sorry, I know every time I leave, like the viewers half or something like that. So let's see. Another similar scan. It's a TCP window scan, right? So we were checking what's the difference between these two. I'd really like to see actually how the packets looked. You know? But I guess it's not actually doing anything different. What it's different is that this one looks more at the RST packet. Examines the TCP window field of the TCP packets returned. So we could actually just like copy this, because this explains why it's called window scan, right? So let's make notes, and we'll need an example. So we have SW, and it's almost kind of funny that that all of the letters are still there available. Window scan. Egg flag. Oh yeah. Set. I was thinking same as egg scan, but examines the TCP window field of the RST packets returned. But I didn't really get what it really sees the difference, how it sees the difference, what information it gets from this. Because it doesn't say, right? Launching the TCP window scanning against the Windows system for information of the console output. Result of the window scanning against the Windows with no firewall, then given extra information compared to the XScan. However, as you would expect, if you repeat a TCP scan,
Generalissimo 269 says,
"What's up?"
Sup.
All good here. You? We're doing the Nmap rooms in the general
Life
implementation
sucks.
tester. Life sucks. That's no good. Can we help in some way? Can I help?
Cocaine 1 PT says, Generalissimo 269 yo noob. Generalissimo 269 says,
Cocaine.
So let's quickly continue through these rooms so we done with them then. I hope there's information to be gained, of course, knowledge to be gained, but so far not much. Let's see. However, as you would expect, if we repeat our TCP window scanning as a server behind a firewall, we expect the more specifying results. In the console output below, the TCP window scan pointed that 3 ports are detected as closed. This is in contrast with the XScan that labeled the same ports as unfiltered. Okay, so we get more information. Okay, yeah, but if they're still closed. So we could have seen an open port, but these would just not select through the firewall then. Although we know that these 3 ports are not closed, we realize they responded differently, indicating that the firewall does not like them. Okay, so they're not closed in the firewall, because they are the only open ones. But on the machine, they might be closed. No? So why does Nmap say closed? If we realize they're not closed, right? Well. Let's. I'm guessing we'll have example scans in a bit, so I'm going to copy the example and paste it in the notes. And good afternoon, Generalissimo. I hope your day gets better than it is. So, one more and then we do stuff. Custom scan sounds interesting, right? Custom flag set? Question mark. Something to play with. So I'll made notes for these. We probably should say like flags. I can change it later. And my nose keeps itching. Darn allergies. Custom scan. If you want to experiment with a new TCP flag combination beyond the built-in TCP scan types, you can do scan flags. For instance, if you want SYN, reset, and FIN simultaneously, you can do so using. Okay. Oh, that's so ugly. Set flags by using their names. Their names with no spaces. So ugly. So, and there will be an example, right? I can make an example myself. Let's do that. I'm sorry for not hopping. So we'll definitely need sudo nmap, and then we do scan flags RSTSYNFIN, as their example was. Let's also add an IP, I guess. Let's do the same one as above. There. As shown in the figure below, if you develop your custom scan, you need to know the different ports will behave. Let's switch over. You need to know how the different ports will behave to
Tonight is
interpret
Eurovision
the
Fix It.
results. Oh, okay. I think I haven't seen that since I was a kid. But maybe it's nice for kids, like, maybe, right? Right, tonight I have Gar's event, right? It's Thursday. You should join
I'm
sometime.
a kid.
Yeah. I mean, since I was like 7, 8, maybe. Yeah, but I mean,
I'm 8.
go for it. Enjoy life. We just talked about the AI and will the world will AI, when it eventually arrives, destroy us, or not.
Enjoy life.
I mean, enjoy life however it is, That's the only thing you can do.
My internet provider has area problem.
Okay. Then you'll have to go touch grass.
Can't even connect to other close APs as they have the same provider. Life
But
sucks.
you're here.
Do you understand that?
Life never sucks. It's just to turn it upside down and see the good parts.
Touch grass is stupid. Hotspot is the solution.
Oh, people, you. Actually, I
But
did a
it's
test
slower.
stream yesterday. I made a new OBS that's actually going to be for my other Fixit 42 and Winding channel, and that one I'll do crazy stuff
I'm
like
not a
touch
dog.
grass.
I won't touch the grass.
Oh, let's find some fun ruins to explore, or something in the forests in Sweden. Right? We're going to Stockholm City and explore. And look at old buildings and eat food at some odd restaurant or whatever. Right? On stream, wouldn't that be fun? Or do some crazy running around in the forest. Someone calling it Blair Witch style.
Sounds boring.
So what's the most interesting thing? Digging into Nmap scans. Testing all the possible combination of flags set on all the possible operating systems existing and having existed ever.
Drugs are more interesting, actually.
Nah, never drugs, never.
Family
And
stream.
Yeah, right, so I don't want you to mention those in the stream, as you know already. So you can choose which flag to be set. So, I think we could continue, but we could just talk, I'm available to talk in chat. That's the whole thing. It's a stream, right? I don't want to just sit here and read stuff. I want to talk to you. So, how can we make your day better? If it's not touching grass, but you're in here, right? You can hear me. Apparently you're responding to me. You have internet, right? Then life's good, isn't it? When you have internet, you can do anything. You have the whole digital world to explore. Maybe I should read it not just quietly. Finally, it's essential to note that the Axe scan and the Windows scan very efficient at helping us map out firewall rules. However, it's vital to remember that just because a firewall is not blocking a specific port, it does not necessarily mean that the server is listening on that port. For example, there's the possibility that a firewall rules need to be updated to reflect recent service changes. Hence, ACK and Windows scans are exposing the firewall rules. Yeah. Yeah, but that's too obvious to mention, right? So, the TCP scan below, how many flags? So, TCP Windows scan. I'm actually going to look at the nose. It's just one flag, right? It's just the ACK, we just check the results differently. You decided to experiment with a custom TCP scan that has the reset flag set. What? Okay, sure. And it's a hint even. It's a hint. The VM received an update to its firewall rule set. A new port is... I'm not saying I don't like these rooms. I'm just saying that it might be good for someone else. A new port is now allowed by the firewall after you make sure... I don't want to miss anything though, And I did learn something about the Windows scan, that it's actually just the that it looks more into the, but I didn't know how. I wanted to know more details, so it didn't satisfy my hunger for knowledge. The VM received an update. Firewall rules that a new port is now allowed on the firewall. After you make sure that you have terminated the VM from task 2. Well, you see how long ago I did that. We've been 40 minutes through this thing. Though we've talked a lot, right? And I made food for my kid. Start the VM for this task. Launch the attack box. Once both are ready, open the terminal on the attack box and use Nmap to launch the scan against the target VM. How many ports appear unfiltered? So, time to go to the VM. And we left it here. It's not done anything more. So let's abort this thing. And let's start. So if we look at the notes, we're supposed to do an ACK scan. That's SA, right? So let's do that here. Alright, we could. Yeah, it's the same IP anyway. Which is the wrong IP because we have a new one. So 140. So now Generalissimo, I don't know if your internet is there or not because you didn't answer any more questions. Is your internet down or up? That's a big question now. You can explore both the digital world and the real, actual world, right, at the same time? So, how many ports appear unfiltered? I'm just clicking in the reply here. Oh, well, maybe you can be on the side instead, right? So what is the new port that appeared? And they mean us to compare from this, I assume. Meaning it's 443. And there's also 3 digits in the answer. Is there any service behind the newly discovered port number? So, what do they want us to say? Yes? No, they want us to say no. So we're supposed to test it. Is that it? I'm curious. Because, you know, from the scan only, we can see this. But I guess we're supposed to try, right? So if we click this and actually try this IP. Why not? Why not? So, I'll type it. It's quicker than switching. And I'm actually going to do this. And we don't even have burp up, so we don't need it though. So there's nothing there, it seems. So we could also just have done the normal scan, right? Usually, you know, if I just do Nmap, I can do Nmap, or just do let's do this one. 25.140, right? So let's see. So the difference now is the last one actually really just checked for firewall things. because there's supposed to be a firewall on this one. So this is a good experience to see how it reacts if you just try to scan it. And this is just the basic one. So on the other screen I'm just hopping on to the next one, since we had a yes/no question. And we also checked that it was a no. So instead of just looking at that, let's continue. Spoofing and decoys. In some network setups, you will be able to scan a target system using a spoofed IP address or even a spoofed MAC address. Such a scan is only beneficial in a situation where you can guarantee to capture the response. If you try to scan a target for some random network using a spoofed IP address, chances are that you won't have any response routed to you, and the scan results would be unreliable. The following figure shows the attacker launching the command Nmap S, spoofed IP address. Consequently, Nmap will craft all the packets using the provided IP address, spoofed IP. The target machine will respond to the incoming packet, sending replies to the destined IP address, the spoofed IP. For the scan to work and give accurate results, the attacker needs to monitor the network traffic to analyze the replies. So, if we look at the image, we can see it's more gray than black now. Black on gray instead of black on black. So, well, yeah, of course it will send it to the other IP. They needed an image for this. So it's where the scan is still getting the same thing a million times here. So in brief, so we finally got the response on the scan. So if we compare this, we have 3 open ports here, but this one is closed. So we got this confirmed, that what we saw here. But I guess this is because there's a firewall, and I don't think I've seen RTT var. Let's actually Google this one, because now we have the opportunity to actually learn new stuff here. So, timing trips and tricks. So, sorry for not reading aloud. Regarding Nmap permits, you put a send, not necessarily. $20 to scan, 30. It just flew through 1 in 10 minutes. So, avoid the DNS resolution. So they had some problem with the DNS resolution. Okay. So that might have been why it did this. We could try that. Why not? So let's first go to the notes. And look at all our information we already have here. We have N, do not reverse DNS lookup. So it's So if we would use the one we had with N, this one, N, will it be quicker? Because it shouldn't be slow, right? I'm curious if it will be as quick as normal, which should be kind of finished now, right? No, we still have the same messages. So I didn't even read what their code was. So use ping scan if you want to know where else side of your network you can use. Whatever. So we're not scanning a network, so that's not very interesting as that. So request failed. Nmap timing tips and tricks. I can't be the only one. I mess around with settings. Oh my god, VV. That's horrible, right? T5. So this says they're doing the full thing on a 24. What? Let's see what people say. Yeah, avoid these until you know what to scan. That looked very odd. Slow because it's reliable. Yeah. Oh, whatever. That's not interesting. This might be interesting. Okay, so round trip time variance. Okay, that's what it is. So they're asking what it is and saying what it is. By the way, no, not that kind of Windows. Window, not Windows. There, the scan finished with the same results. So, took the same time. I thought so. Since it was just, one, not network scan. This might be a question for ChatGPT. Because when you Google common words, you can get problems. So, but maybe we found it. So, Windows Scan is exactly the same as Xscan, except that it explains an implementation deal of certain systems to differentiate open ports from closed ones, rather than always printing unfiltered when an RST is returned. It does this by examining the TCP window value of the RST packets returned. On some systems, open ports use a positive window size, even for RST packets, while closed ones have a 0 window. Okay, so that's what I was looking for. So it's a size there. That's what it goes on. Windows scan sends the same there. Yeah. So it's just that we response. The scan relies on the implementation detail of minority of systems out on the internet, so you can't always trust it. Systems that don't support it will usually return all ports closed. Of course, it's possible the machine really has no open ports. If most scan ports are closed, but a few common port numbers such as 22, 25, 23, 53 are open, the system will most likely be susceptible. Occasionally, the system will even show the exact opposite behavior. If your scan shows 997 open ports and 3 closed filler ports, then those 3 may very well be truly open ones. Nice. Very logical. But I like it. Well, the scan is not suited for every situation. It can be quite useful on occasion. Recall a fin scan of a DOS. Okay, so which shows many open filter parts not found in the basic fin scan. The problem is that we can't distinguish between open and filter ports with a fin scan. The previous section showed that we could distinguish between by commanding fin and ACK scan results. In this case, a Windows scan makes it even easier by requesting the fin scan results. Example 517 here. So these results are exactly what eRead wanted. The same 39 interesting ports are shown as when FinScan, but this time it distinguishes between the 2 filtered ports, MSSQL and MSRPC, filtered here. 14 open ports omitted for brevity, and 30 so that are actually open. These are the same results as eRead obtained from combining fin and ACK scans results together in the previous section. So there was no more details than this, and I guess that's the only thing we need. So on some systems, open ports use a positive window size, while closed ones have 0 windows. So this is what I was looking for. So let's tab to notes and actually add this, because same as ACK, but examines TCP window field. On some systems, open ports use a positive window size, while closed ones have a 0 window. And that's the only thing. This is used to distinguish between open and filtered ports, unfiltered ports. There. So we have it all in the notes. It's kind of long. I prefer them just to be one line. All of these are too long. Well, we have the information, so that's what they could have just added this line to the room. I would have been pleased. So what was this? It's just an example scan they compared to. Okay. Oh my nose itches. Thorn allergies. So RTT var is round trip time variance. Good. This will keep up. I want to look at it. Let's actually move this one so I don't.
Patrico says, and
welcome in. So we're looking at Nmap rooms. It's the junior penetration tester path. So wanna have this. I wanna see if there's anything more to learn here, even though the one thing that I learned was not detailed enough. Well, we know more. We have more information. The hunt for knowledge. In some network setups, you will be able to scan a target system using a spoofed IP address. Yes, I read this. So, right, I stopped reading because, oh my god, my nose itches so much. I'm going crazy. Ah, sorry. So when the Nmap scan was done, I hopped over there. Yeah, that was the basic image. I think it was what we were kind of here, right? In brief, scanning with a spoofed IP address is 3 steps. Attacker sends a packet. Oh, it's the same as the image. In general, you expect to specify the network interface using E and explicitly disable ping scan. Therefore, instead of Nmap S spoofed IP, you will need to issue Nmap E net interface PNS spoofed IP to tell Nmap explicitly which network interface to use and not to examine and not to expect to receive a ping reply. It's not worth repeating that the scan will be useless if the attacker system cannot monitor the network for responses. Yeah, so when you are on the same subnet as the target machine, you would be able to spoof your MAC address as well. You can specify the source MAC address using spoof. So I'm thinking notes here, of course, as always. So let's add a header in the notes. Spoofing IP and MAC. There. And E set network interface a capital S set IP to spoof. No, it's actually, yeah, right. I got it. So, because they're saying spoofed IP when they mean IP, and then there was another IP, and I realized, okay, it was the whole command. So that's why it was like that. So let's add the example here. There. And then we have the spoof Mac one. there. Let's go back and read a bit more. I just wanna don't read too much and then make notes, you know. So you can specify source MAC address using this. Address spoofing is only possible if the attacker of the target machine are using the same Ethernet. Spoofing only works with a minimal number of cases where certain conditions are met. Therefore, the attacker might resort to using defaults to make it more challenging to be pinpointed. The concept is simple. Make a scan appear to be coming from many IP addresses so that the attacker's IP address would be lost among them. As we see in the figure below, the scan of the target machine will appear to be coming from 3 different sources, and consequently this will go to the decoys as well. I'm just trying to read the text at the bottom. You can launch a scan by specifying a specific or random IP address after D, for example. Decoy scan. Okay. Sorry. It's allergies. Maybe I should eat a bit while doing this. Maybe that will help. I have this wonderful thin bread again. Love it. So, I think I had a better, yeah. Let's see if this can make me cough less. You can launch a decoy by specifying a specific or random IP address after D. For example, IP, ME, IP. So ME, we'll see what that is soon. We'll make a scan of a pair coming from where ME to indicate your IP address should appear in the third order. Okay, so hours lost. Another example command would be rnd-me, where the third and fourth IP address are assigned randomly, while the fifth source is going to be the attacker's. So we will actually use ME, right? It's just their short form, and we should add our IP there. It should be able to find it itself, right? Possibly. I mean, with the R&D, it's very odd to me. Well, the fifth. In other words, each time you execute the latter command, you would expect 2 new IP addresses to be the third and fourth. Okay. What do you need to add to the command to make the scanner pairs coming from the IP address? So, S. dash s 10 10 10 11. What you need to add to the command sudo nmap to make it appear as coming from the IP addresses in addition to your IP address. Yeah, so it's 2 at the end there. And we need to make also right. Yeah, so lots of typing. 10 10 20 21 comma 10 10 20 28 comma me. So we need to make notes for the D1, and I would have liked to have actual example scans for this, and they didn't have that, so we'll have to do it ourselves, I guess, which is not good. I guess that's why, but why didn't they have examples? Oh well, we could do it. It's not like it's. We don't even have an example of this. No example. Whatever. So let's do the D. Some IP. Some IP. Well, this is not good. Decoy scan. Appearing to have several origins. Oh my god. How did I get a P in there? And let's have several examples here. Because we have them available, so I can just copy them in there. There. So ME is our IP. R&D is a random IP. I'm thinking IP. That's better. So I guess we'll continue. Data. Apparently. Fragmented packets. Firewall. A firewall is a piece of software or hardware that permits packages to pass through or blocks them. It functions based on firewall rules, summarized as blocking all traffic with exception to allowing all traffic with exceptions. For instance, you might block all traffic to your server except those coming from your web server. Traditionally, a traditional firewall inspects at least IP header and transport layers. A more sophisticated firewall would also try to examine the data carried by the transport layer. IDS, Intrusion Detection System. Right. The question is, do I have IDS in my acronyms list? I'm not sure. Let's look. I don't, so just to make sure I don't forget it, because it's not like it pops into my head at once. So there, intrusion detection system. And you're still on the left screen. Good. inspects network packets for select behavioral patterns or specific content signature. It raises an alert whether a malicious rule is met. In addition to the IP header and transport layer header, an IDS would inspect the data contents in the transport layer and check if it matches any malicious patterns. How can you make it less likely for traditional firewall IDS to detect your Nmap activity? It's not easy to answer this, however, depending on the type of firewall IDS, you will benefit from delivering the packet into smaller packets, fragmented packets. Nmap provides option F to fragment packets. Once chosen, the data will be divided into 8 bytes or less. Adding another FFF will split data into 16-byte fragments instead of 8. You can change the default value by using the -MTU. However, you should always choose a multiple of 8. Now let's just click this image. There was nothing else there. No text, I didn't see, that is. This is a bit far-fetched, I think. Maybe. We'll see. I guess I should have it in my notes anyway. To properly understand fragmentation, we need to look at the IP header in a figure below. It might look complicated at first, but we notice that we know most of its field. In particular, notice the source address taking 32 bits, 4 bytes, and I'm not listening to myself. More bread. To properly understand fragmentation, we need to look at the IP header in the figure below. It might look complicated, but we notice that we know most of its fields. In particular, notice the source address is taking 32 bits. Right, source address here. 4 bytes on the 4th row, while the destination address is making another 4 bytes on the 5th row. The data that we will fragment across multiple packets is highlighted in red. To aid in the reassembly of the packet's size, IP uses the identification ID and fragment offset, shown in the 2nd row. Identification and fragment offset. Shown on the 2nd row in the figure, so there were no more text up there. So version, IHL, type of service, total length, identification flags, time to live, protocol, header checksum, source address, destination address, options padding, and the data. And there we can have multiples of 8. So, I'm not sure how to put this in the notes, but I'm starting as fragment packages. And we're doing F. Mm. 8 byte segments. FF 16 byte. MTU. Set default. Value, let's do value as they do. Multiple of 8. So I just added this there. So let's continue below. Let's compare running sudo nmap ss. Let's do that just to make sure. Time flies. Let's compare running sudo nmap ss. I have not used this, by the way. P80 and sudo nmap. So the difference is this has also the F. As you know by now, this will use stealth, TCP syn, scan, port 80. However, in the second command, we're requesting Nmap to fragment the IP packets. In the first 2 lines, we can see the ARP query response. Oh, I want to look at this first. Well, whatever. Nmap issued the ARP query because the target is on the same Ethernet. So second 2 lines to a TCP syn saying reply. The 5th line is the beginning of support scan. Nmap sends TCP syn packets port 80 in this case. The IP header is 20. TCP header is 24. Note that the minimum size of the TCP header is 20. So, first ARP. Then we have TCP. Syn. First attack. Can we click this? No, we can't see more. Whatever then. They're talking about the sizes. I don't see a thing of that. Let's just cut off. With fragmentation requested via F, 24 bytes of the TCP header will be divided into multiples of 8 bytes. With the last fragment containing 8 bytes or less of the TCP header. Since 24 is divisible by 8, we got 3 frame packets. It's just 20 bytes of IP header and 8 bytes of TCP header. Right. Yeah, so that's what I was thinking there. We can see the 3 fragments between the 5th and the 7th line. Okay. Fragmented IP protocol. I mean, how could this be 5 and 6, 7 in this? That's what I kind of was looking around for. 7th line in a 5-line one. So we had some. Oh. Let's compare instead. I assume these are not the same. These say fragmented. So 1, 2, 3, I assume then. But if we can't see all of the full lines. Note that if you added FF or FF, the fragmentation of the data would be a multiple of 16, in other words, 24 bytes, 2 fragments. On the other hand, if you prefer to increase the size of the packet, you can use little notches. Data length num. I guess we'll need to add that one too. Data length. Well, I'm kinda like, when would I use this? Maybe I would, but at least it's new stuff. That makes me happy. So let's... Oh. Yeah, so... So we compare these two. We don't need that. If a TCP segment has a size of 64 and f has to be used, how many frames? So let's just a math. 64 through 16. Well, idle zombie scan. Spoofing the source IP address can be a great approach to scanning stealthily. However, spoofing will only work in a specific network setup. It requires you to be in a position where you can monitor the traffic. Considering these limitations, spoofing your IP address can have little use. However, we can give it an upgrade with the idle scan. The idle scan or zombie scan requires idle system connected to the network that you can communicate with. Practically, Nmap will make each probe appear as coming from the idle zombie host. Then it will check for indicators whether the idle zombie host received any response. Seriously, let's do this. Or maybe I shouldn't have selected all of it. Let's do this bit just.
The idle scan, or zombie scan, requires an idle system connected to the network that you can communicate with. Practically, Nmap will make each probe appear as if coming from the idle, zombie, host, then it will check for indicators whether the idle, zombie, host received any response to the spoofed probe. This is accomplished by checking the IP identification, IP ID, value in the IP header. You can run an idle scan using map si zombie _IP 10.10.25.140, where zombie _IP is the IP address of the idle host, zombie. The idle, zombie, scan requires the following 3 steps to discover whether a port is open. Trigger the idle host to respond so that you can record the current IP ID on the idle host. Send a SYN packet to a TCP port on the target. The packet should be spoofed to appear as if it was coming from the idle host, zombie, IP address. Trigger the idle machine again to respond so that you can compare the new IP ID with the one received earlier. Let's explain with figures. In the figure below, we have the attacker system probing an idle machine, a multifunction printer. By sending a SYN/ACK, it responds with an RST packet containing its newly incremented IP ID. The attacker will send a SYN packet to the TCP port they want to check on the target machine in the next step. However, this packet will use the idle host, zombie, IP address as the source. 3 scenarios would arise. In the first scenario, shown in the figure below, the TCP port is closed, therefore, the target machine responds to the idle host with an RST packet. The idle host does not respond, hence its IP ID is not incremented.
IP ID. Oh, I got it. I got it.
In the second scenario, as shown below, the TCP port is open, so the target machine responds with a SYN/ACK to the idle host, zombie. The idle host responds to this unexpected packet with an RST packet, thus incrementing its IP ID.
Because now it's sending a package. And it didn't before.
In the third scenario, the target machine does not respond at all due to firewall rules. This lack of response will lead to the same result as with the closed port, the idle host won't increase the IP ID. For the final step, the attacker sends another SYN/ACK to the idle host. The idle host responds with an RST packet, incrementing the IP ID by 1 again. The attacker needs to compare the IP ID of the RST packet received in the first step with the IP ID of the RST packet received in this third step. If the difference is 1, it means the port on the target machine was closed or filtered. However, if the difference is 2, it means that the port on the target was open. It is worth repeating that the scan is called an idle scan because choosing an idle host is indispensable for the accuracy of the scan. If the idle host is busy, all the returned IP IDs would be useless.
Yeah. There, we couldn't see the difference then. Oh. We'll have to make notes. So... this is a bit of a specific thing, right? So... we'll have to make put the useful ones at the top. Let's actually call it... I guess we could just have them like oops. I'm thinking I'm adding something here because these are not like main headers. They're just part of the more advanced bit. So if we were to we want to see what's below this, we just go there. Well, SI, well, it's not visible in this font, but that's an I. Idle scan. Zombie scan. And this is quite a bit different. I would like to have like a... I'm thinking their images were too detailed in this room, as they're always in this room. So, I guess we'll just type it out. So, the zombie IP needs to be machine that has no network traffic as the what it's actually called. Whatever. That's the packet ID number that is incremented for every packet sent is used. First, our machine sends Synac to the zombie and records the ID. Then we send, well, we in our machine, whatever. Then we send a packet to the machine we're discovering. With the zombie IP as is it allergies making me itch now too? So annoying. I'm sorry. I think I'm going to source so depending on if the zombie the target, let's use target, to the target, that's much shorter. For the zombie IP as a source, depending on the target, response to the zombie target sending RST makes zombie send nothing. target sending Synac makes, I'm trying to be consistent here, makes, oh, I misspelled zombie again, make, it's just me typing too quickly, with E and W being next to them each other. I'm not a good typer, in other words. Target sending Synac makes zombie reply with RST. The packet counter will increase or not. Didn't I? Okay, maybe my keys are actually getting bad. Maybe it's not just all me needing to practice typing. Oh my nose. So I'm also typing this in the wrong place, right? Because all the other places we put the information. Why do I have a dot there? So it's supposed to be there. The packet can't really increase or not. Then we send another packet to add, check if the counter has been increased or not. Dot. Short command for lots of text. So let's answer the question here too. So S capital I, which is not visible, looks like an L, and then we have 10 5 5. Oh my darn, oh my nose itches so much, it's annoying. Let's just check this first, because I did click this by mistake before, so we will get something more to add here, but just confirm that we have all of these two in the notes. Spoofed, spoofed Mac. Yeah, though our notes are more complete. They also have pseudo here and not here. Being a bit interesting, right? Though it's not important really, because we're always on the machine we send these from, we're always have pseudo permissions. Oh, well, not always, maybe, though. But probably. So, I'm assuming these are from this one. We'll add them. Reason sounds like an interesting one. These contacts rely on setting TCP flags and expected ways to prompt ports for reply, null fin, Xmas. Response for open and close parts. Ensure everything down. So it's just because I used this to not hop over, not destroy the streak yesterday. Maybe I shouldn't care. But it's kind of fun though, right? It's one of the motivating factors to be consistent with your studies. Well, I guess we shouldn't hop to the next one when we end this one, but look at those once more. You might consider adding reason. If you want Nmap to provide more details regarding its reasoning and conclusions, consider that 2 scans below to the system, however the latter adds reason. So let's compare them. Cute that is pentest retro hack me. So host this up, received ARP response. So this is a new line there. Instead of just host this up and latency. So it's just a received ARP response that I did. And then the reason is resets. So this is very good for learning, I think, because we know more about what the actual traffic is. Then we have the port. And in one of these lines we have the reason added at the end. Oh my god, my nose itches, I'm so sorry. There nothing more added. Providing the reason flag gives out the explicit reason why Nmap concludes that the system is up, or a particular port is open. In this console output above, we can see that the system is considered online because of the received ARP response. On the other hand, we know that SSH port is deemed open because Synapse packet back. For more detailed output, you can consider using V for verbose and VV for very even more robustity. And I think I tried this, and it's very annoying because you can't find the information when you do VV. It's too much, you know, and I'm saving those outputs. It's just annoying. But I guess doing them a few times. Because if you're just looking for, you know, the information about the ports. Oh, we'll use both here. No? So the reason is automatically when you do VV. You get the reason automatically. Initiating ARP ping scan. Scanning. Completed ARP ping scan. Initiating parallel DNS. So it didn't say that it got a response, right? Initiating parallel DNS resolution completed. Syn scan. So I'm not sure I like this at all, right? I agree with myself. Completed Syn stealth scan. Nmap scan report. So the reason is nice, but this is not good. Here it says that hosted sub received ARP response, but it didn't say up here when it actually did the ARP request. It should have said there, right? If it were to be like logical. If VB does not satisfy your curiosity, you can say D for debugging or DD for even more details. You can guarantee that D will create an output that extends beyond a single screen. Yeah, of course. Launch the attack box if you haven't done so already. After you make sure that you have determined the VM, terminate the VM from task 4. Start the VM. This task do they have to say this? It's all these things we do for all of them, right? Wait for it to load completely. Open the terminal. Couldn't they have just said use this, right? To scan the VM. Sorry that I get annoyed at tiny things like this. I think they shouldn't be too over the top. So F. Reason. 10, 150, 181. Yeah, and we need sudo. Of course. So, let's see it for ourselves. Reason. So that's why it's up, and it received a Synac here. So let's compare it to this. That's the whole point, right? Comparing them. So we didn't get this, and we didn't get this one. So to reply to the question, it's an ACK. And I'm thinking I'll abort that hop there. And we need to add it to the notes, of course. So I'm looking at the notes here, and I'm thinking that these are actually useful, right? We don't want them too far down. But they're not scanning a network really, but it's interesting for port scanning. So specify ports to scan, specify scan speed. So I'm thinking this one is actually more like here. Specifying verbosity, right? And these are 5 level headers there. So let's do the same. And we have reason, and we have Y is a host up, a port, open. Then like V and VB, we don't even have to type anything, right? It's obvious. So VB, and we have D, DD. Verbosity. That looks wrong. Oh, very wrong. High verbosity. Oh well. Higher. And debug mode. More details. That's enough. So I guess these are what we added here, right? Yeah. Specify source port number and data length num. Did we actually have these in the notes? I don't think so. Scrolling. Data length is there. Source port is not. So I'm curious. What did I miss? It was not in here. Yeah, I guess it's only in the summary, right? So why only in the summary? Is it not worth it so? Or have they moved stuff and forgot to remove it from the summary? We'll see next room, right? So let's add this here. I'm thinking this is more like controlling where the reply goes. Then the port could fit here, the source port. It's kind of more better to put it here somewhere. Port to scan. Let's put it here. It's not ports to scan, but I don't know why we would set the source port. Could some detection or firewalls care about that? And then it's more like, oh, whatever, it's in the notes now. So if I search for it, I will find it. We could be nice and terminate, right? So let's hop to the